So we said that memory is like a series of on-off switches. When the switch is on, it represents a 1. When the switch is off, it represents a 0. We've seen how we can represent numbers using just ones and zeros. And we've also said that everything stored in the computer is a number. So let's see how that could actually be used in practice. So if everything's a number and we want to store a letter, what we could do is we could say that 0 stands for A, 1 stands for B, 2 stands for C, and so on until we got the whole alphabet. And then we could use the numbers from 0 to 25, and we could represent lowercase letters A through Z. So to represent the numbers 0 through 25, you need a certain number of bits. How many bits would you need? Well, if we count from 0 to 25, when we get to 25, we can see that there are 5 bits needed because 25 is 11001, and so there's 5 bits there. So if we have 5 bits of memory for each letter, then we can spell words and possibly write sentences, although we haven't accounted for spaces in sentences or punctuation yet. But that just means we need more bits. So whatever you decide what number stands for what letter, we call that an encoding. And one very simple encoding is called ASCII. It's a little bit outdated, but it's simple, and for our purposes, we're just going to use that because it just makes things a little bit easier. It doesn't store very many letters. If you wanted to type in Chinese, for example, it doesn't work. You have to use a different encoding. So the ASCII encoding uses 7 bits. There's an extra bit which has another purpose, but 7 bits gives you 128 separate characters. And we can see that in this chart. This chart shows the decimal value from 0 to 127. It also has the number in hexadecimal. And then the third column is the actual symbol. And some of the symbols have funny sort of names, shortened names for them. So I said earlier that ASCII is a little bit outdated, and it doesn't handle languages with lots of characters. If you did want to use a lot of characters, you'd use something called UTF, and that provides a lot more bits for the characters, so you can have more complicated alphabets and symbols.